Okay, so for part 1, they ask us to write down the simple space. For every question that asks you to write out the simple space, you have to indicate that the simple space is a set. Even you draw this table, you still have to indicate that the simple space is a set and then list out all the elements. This table is more like a visualization aid so that we can think of what is going on. For the question that involves throwing 2 dice or throwing a die twice, I would write out a table like this. For example, I can say the number here represents for the outcome in the first row, and the number in the columns here represent for the outcome in the second row. Or you can switch them, that doesn't matter at all. So you will write down what is the outcome that we have. We have the first combination of outcome here, that is 1 and 1. And then the second combination is 2 and 1. And then 3 and 1. And then we have 4 and 1. Something like that. Up to 6 and 1. And then we do the same thing. We have 1 and 2, 2 and 2, 6 and 2, and then 1 and 6, up until 6 and 6. In the midterm or in the final exam, to be safe, just list out all the elements. Don't write ... like me. Try to list out all the elements because it really depends on the TA, whether they mark harshly or something. So to be safe, just list out everything. And remember the set notation. The second question, the first one asks us when the first outcome is 4. So we will look at it. When do we have the first outcome is 4? The first outcome is represented by the number here. So everything in this column would have the first outcome is 4. So I will define A is an event where first outcome is 4. Make sure to define any new set that you want to use. And then I will write down what is A. And then I'm interested in probability of A. Since every number here has the same chance to be landed, then we have equiprobable events for each of the events here. They have the same probability to happen, which is 1/36, right? Because our simple space have 36 elements, like 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3, 4, 5, 6, 6 row and 6 column, which give us 36 elements in total. I will write down the elements that belong to A. This one here is 4 and 1. This one here is 4 and 2. This one here is 4 and 3. And 4, 4, 4, 5. And then 4 and 6, like this. And since it is equiprobable event, probability of A is equal to number of elements in A divided by number of elements in the simple space. And how many elements are there in A? 1, 2, 3, 4, 5, 6. And then the simple space have 36 elements. So that is the answer for part A. Next, we want to know probability that the product of the two outcome is 12. So since we are interested in the product of the two outcome, you can see that my intersection between any row and column, the intersection is a product of my first outcome and my second outcome. For example, like this one, my first outcome is 4, My second outcome is 2. So the product is 8. So I fill it in. If the question is interested in like the sum or the difference, something like that, then your value of intersection should also change correspondingly. If I define my event B to be when the product of the two outcome is equal to 12, I will list out what is B. So I will have to look for where the intersection is 12. So I have here, 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 and here. So there are 4 intersections where we have the product is 12. The first one is when first outcome is 6, second outcome is 2. So I have 6, 2. This one, first outcome is 4, second outcome is 3. So I have 4, 3, and 3, 4, 2, and 6. And then I have probability of B is number of elements in B divided by number of elements in the simple space, which is 4/36. Does this make sense for everyone? If there is no question, I will let you work on question 2 here. So let's recall the definition for decreasing sequence. We say that the sequence like an minus 1, an minus 2, and then I1. We call this is a decreasing sequence. Actually, I think I should reverse it. So it's more intuitive. Like I1, I2, I3, an minus 1, and an. This decreasing sequence, if you have I1, like I2 is subset of I1, I3 is subset of I2, an minus 1 is subset of an minus 2, and an is subset of an minus 1. So this is the definition for decreasing sequence. And they're giving you here the definition for an. For example, like this number pi over 4 is produced by selecting this digit 7 and selecting 8, selecting 5, something like that. Similarly, like 04 is from selecting 4, 0, 0, 0, 0, everything else is 0. So we have the event an is when the first n decimal digits are equal to 1. So for example, you have A1 consists of the number such that the first decimal digit is equal to 1, like 0 0.10, 0 0.11, 0.12, something like that. Anything that have the form 0, 1, something, something after it would belong to A1. How about A2? A2 consists of the number such that the first 2 decimal digits are equal to 1. So it will contain the number of the form 0, 1, 1, and then something after that. It can be any number after that. Okay, so that is the definition for like A1, A2, and you can generalize it for AN. And this is what we want to show. We want to show that AN is subset of AN minus 1. AN minus 1 is subset of AN minus 2. And up to like A2 is subset of A1. I will leave you time to think about this. But in other words, what we want to show is that AI plus 1 is a subset of AI for every I greater than or equal to 1. This is not like a long argument. I think just a few lines and you can show it.
Could we? Oh, am I allowed to answer?
Yep.
Could we pick an element from? I mean, maybe we can use induction in at this point.
Yeah, it's possible to use induction, but I don't think everyone in this course exposed to induction before. But definitely if you like proof by induction, you will not get your mark deducted, but it's not necessary. As long as you can prove this arbitrarily, it will be generalized for every I greater than or equal to 1. Does that make sense?
Okay. Yeah. So basically, if we pick, like, for example, any element from AI plus one, and we show
Mhm.
that the elements inside AI, then
Yeah,
we've
yeah.
essentially proven.
Yeah, exactly. Recall that I think in the previous tutorial, we talked about how to show that A is a subset of B. So it depends on the problem. Like if they allow you to use Venn diagram, then you can use it. But yeah, like it really depends on the problem. But I wouldn't say it is a formal proof. Another way you can do is to show that if some element is in A, then that element is also in B, which means you should just pick any element in the set AI plus 1 and you show that that arbitrary element will also be in the set AI. Then it will prove that AI plus 1 is a subset of AI. Okay, let's start with like pick arbitrary elements. And I will call that element X. And X is an element of AI plus 1. So I will pick an arbitrary element from the set AI plus 1. And then after some arguments, I don't know what is that yet. But my conclusion, I want to reach to X is also in AI. Okay, that is my goal. So if X is in AI plus 1, what does it mean? AI plus 1, by this definition, means that the first I plus 1 decimal digits are equal to 1. So X would be equal to a 0.11 and 1, and then something after that. I don't really care. But this has the first n plus 1 digits is equal to 1, right? Which means that X has first I digits equal to 1. Does this make sense? Like how I go from this step to this step. For example, like if you have x is 0.111 something, which means x is in A3, and the first 3 decimal digit is 1. But it also means that the first 2 decimal digits is 1, right? So if I have x equal to, like the first I plus 1 decimal digit is 1, and something append after that, I don't care. It also means that the first I digit here, like exclude this one, the first I digit here is also like all number 1, right? So x also has the first I digits equal to 1. And it just matched with the definition of AI. AI consists of the number such that the first I decimal digits is equal to 1. Does this make sense, or is there anything confusing? Any step doesn't make sense to you? Make sure that you understand this.
Sorry, I have a question.
Yes.
I'm just gonna be entirely honest with you here. I don't even understand like what the question's trying to ask. Would you at least help explain what the question's asking for, and everything else I'll just figure out for myself?
Yeah. So do you understand the part like how they define an?
Sort of. I wouldn't mind if you explain it again though.
Yeah. Okay, so they were talking about like the random experiment to select a real number belong to this interval. So for example, the number like 0.5 is the same process as you pick the first number is 5, and the second number is 0, the third number is 0, like every number after that is 0. Okay, or like this number here, 0.785, like this.
I get that part.
Yeah.
Yeah.
And then you would have like a1 by the definition here. If I copy this definition and instead of the n, I use the 1, like the first 1 decimal digit of the number drawn are equal to 1. So it would consist of all the number of the form like 0.1 something, right? Because
Yeah.
like for all those number, like the first decimal digit is 1. And then you have 2, A2 is 0.11 something, right?
Oh, okay.
Because like the first 2 decimal digit is 2, and then A3 would be like 0.111 something.
I get it.
So they are asking you to prove that this set is a subset of this.
I get it now. Yeah.
Yeah, basically because every element in here, it also starts with 1. So it should be the element in this set as well.
Okay, I think yeah, it makes sense. Thank you.
Yeah. Any other question regarding this one? Okay. If you need more time to think, each digit an element? Not each digit is an element. This one, it means that every element of A1 has this form. So an element is like 0.1, 0.12, 0.11, 0.11111. Like an element would be some number in the interval 0 and 1. How would it be a subset? So we are talking about like AI plus 1 is subset of AI, right? For example, you can say that A2 is a subset of A1 because A2 is a set and A1 is also a set. And then for every element in A2, no matter what element is that, you can always find it in A1 because every element in A2 also has this form. Does that make sense? Yeah. For example, like if you pick from A2 some element like 0.1122, this element should also appear in A1 because it definitely has a form of 0.1 something. If there's no question, I will let you work on question 3. I think it is pretty straightforward, so maybe 2 minutes. During that time, if you are still confused about question 2, you can let me know. Did anyone got the answer for this part? How many ways they can choose to sit? So you have 3 friends and they want to sit together. So you can think of it as like 3 consecutive empty spots. And then how many ways they can choose to sit is like how many ways you can arrange them. You can arrange Nina, Lisa, and Wendy. So for the first spot, how many choice do you have? How many options that you can put in the first spot? Yep, that sounds correct. You have 3 options for the first spot, right? Because you have 3 friends. So you can put any one of them in here. How about the second spot? 2, right? And then the last spot, you will have 1, right? This is true because whoever you put in the first spot, let's say you put Lisa in the first spot, then in the second spot, you can only put Mina or Wendy, right? You cannot put Lisa twice. There's only one Lisa. And then the last spot is whoever you have left after arrange the seat for the first and second position. So in total, you would have 6 ways they can choose to sit. And how many ways they can sit if Lisa insists on sitting in the middle? So we would just put Lisa sitting in the middle. There's one way to arrange who sit in the middle, which is Lisa, right? And then I will decide who sit in the first spot. Since Lisa is seated in the middle, there are only 2 options, Mina or Wendy, for the first spot. So I have 2 options. And for the last one, I have to put whoever left. For example, if in the first spot, I put Mina, then in the last spot, I only have Wendy left. Or if I put Wendy in the first spot, then for the last spot, I only have Mina left. So only one choice. So you would have 2 ways to arrange the seat if Lisa is in the middle. Does this make sense? Okay. For the last one, I will give you maybe 2 or 3 minutes to think about it, and then I will pick it up. Okay, one thing before I give out the solution is that this is not the only solution. You might be able to count it in different way and it can still be correct as long as you do everything correct. So I will start with the easy condition, which is this one. The first two positions have to be digit, and then the password contain exactly 2 digits. And then the password is 8 characters in length, which means that the first two positions here have to be some kind of digit. And since the password contains 8 characters, we have 6 spots left. And they have to be all letter because the password only contains exactly 2 digits and we only have the 2 digits here already. So the rest of them have to be letter. So the underline that I put in blue represent for digit spot and the one in red represent for letter spot. So we will first start with the digit because it's easier to deal with. It is less restriction here. How many choice I have for the first one? For the first spot, it can be any digit from 0 to 9. So how many choice do I have? Yes, I have 10 choices. How about the second digit? Yep, it's also 10 because we don't have any other restriction such that like 2 digits cannot be the same. There's no such restriction. So the second one can also be any number from 0 to 9. So we multiply with them, okay? And then we will multiply with the number of ways we can form this letter. It is a bit tricky here because as you see, there's 2 restrictions. First one is that there is no same letter regardless of K, which means that A, like lowercase a and uppercase A, they are not allowed to appear together. Like if you have lowercase a, then you cannot have uppercase A and vice versa. And next one is contains at least one lowercase and at least one uppercase. So if we think about this, I want to form letters that satisfy these 2 conditions. If we think about condition 3, like no repeat letter, we can actually partition this case. It can be partitioned by no repeat letter and all lowercase, or no repeat letter and all uppercase, or no repeat letter and at least one uppercase and at least one lowercase. Does this part make sense? I partition it that way because it will be easier for me to calculate. I want no repeat letter and at least one lowercase and at least one uppercase, right? So if I partition it this way, I can find the value of this set by taking the number of ways I can choose 6 letters such that there is no repeat letter, like only this restriction, and then minus no repeat letter and all lowercase, minus no repeat letter and all uppercase. Then the remaining result will be no repeat letter and at least one uppercase and at least one lowercase. If you don't partition like this and you want to calculate these 2, you will have to do cases. Like, okay, I have 1 lowercase and 5 uppercase, or I have 2 lowercase and 4 uppercase, something like that. And it is pretty long if you do it that way, but it is also correct. I just feel like I do it this way, it will be shorter. Does this make sense? And also, does a partition make sense? Yeah. So now I want to know how many ways are there. I can choose 6 letters such that it satisfies both 3 and 1, which means I will have to find the number of ways to choose 6 letters. No repeat. And then subtract the number of ways to choose 6 letters, no repeat, and all lowercase. And subtract no repeat and all uppercase. You take this one minus this, the result will be satisfy both 1 and 3. Okay. So how many ways are there that I can choose 6 letters with no repeat, regardless of case? So if we think about it, how many ways are there to choose the first letter? Your alphabet would be consist of both lowercase and uppercase, right? The normal alphabet has 26 letters, like from A to Z, there are 26 letters. And if you combine with the uppercase, there's another 26 letters. Yes, I see the student answer, 52, that is correct. So I will write here, to choose the first letter, there are 52 choices. How about the next one, the second letter? Such that no repeat. Is it true that 51? For example, if the first letter I pick A, then I have to cross out both uppercase A and lowercase a, right? Yeah, that is correct. I would have 50 choices. How about the third one? Yes, 48. And I do that for every 6 letter. 44 and then 42. So those are the number of ways to choose 6 letters without any repetition, regardless of case. Next, I want no repeat and all lowercase. How many ways are there? I can choose for the first position if I want all lowercase. If I want all lowercase, then I only consider the alphabet A to Z lowercase, right? I just ignore this alphabet. Yep, that looks right. So I have 26 for the first position, 25 for the second position, because I don't want repeat and I only care about lowercase. And then I have 24, 23, 22, 21. And similarly for uppercase, I only care about uppercase alphabet and I don't want any repetition. So it would be this number here, right? So if I take this number, subtract this, I would have the number of ways to get 6 letters that satisfy both condition 1 and condition 3. So my final answer would be 10 times 10 times 52, 50, 48. 42 minus 2 and 26, 25, 24. So this would be my final answer. And if you see this question in the test, you don't need to like simplify it further. I think the number will be pretty big. Any other question?
Sorry, why did we subtract, or not why did we, what are we subtracting from what here? Like which partitions were we subtracting from each other?
Okay, so like in order to calculate no repeat letter and at least one lowercase and one uppercase, we want this range, right?
Yeah.
Then what you have to do is take the number of ways to form 6 letter with no repeat. Like you take the whole thing here and then subtract. You subtract this branch and this branch because they form a partition. Like think of this whole circle as like no repeat.
Right.
What do I have inside this circle? I would have 3 parts. The first one is all repeat, but all lowercase. Another one would be all like no repeat, but all uppercase. And the rest would be at least one lowercase and one uppercase. Right? At least one uppercase, right? So if I want to calculate this part, what do? I take the whole circle. I subtract this part and then I subtract this part, right?
Right. Okay.
Does this make sense now? Okay, so if there is no question, then it is the end of our tutorial today. Please have a look at the tutorial 4 so you have more time to think about that. And I will see you again on Wednesday.